Now let us see what is the negation case. A function f of xy is said to be an implicit function if y cannot be written in terms of x alone. What does it mean? Now consider this. X into y equal to sine of x plus y. As x changes, I'll get different values of y. But can I write this function as y equal to some function of x only? Can I separate y in this expression and write the rest of the things, all x terms on one side? If I wanted to separate this function sine of xy, I'll end up by having sine x and cos y factors in it, where I cannot separate x terms alone from that of y. So in this, it is very obvious that I cannot express y as a single function of x, isn't it? That's why this function is called implicit function. If it is not possible to express in the form y equal to f of x, then the function is called implicit function. Similarly, one more example, x power y, which is an exponential part, is ln of x plus y. Now, even if we use the expansions of logarithmic functions, then also y cannot be separated from the function, and I cannot write this as y equal to f of x form, right? Y cannot be expressed as an exclusive function of x. That's why this is also an example of implicit function. Now, let us see one more example of the same thing. Now y is present in tan y. The y will also be present as sin y and cos y terms on the right hand side. So sin y term, cos y term and a tan y term cannot be separated and expressed only in terms of x. So this is also not possible to express in the form y equal to f of x. That's why this is also an example of implicit functions. Now here, identify whether the following functions are explicit or implicit. Before we proceed, just recollect what is definition for explicit function. If the function could be expressed in the form y is a function of f, x, then we say it is explicit. If cannot be expressed, then it is implicit. Now let us see this first function. X square minus y square minus 2x plus y plus 1 is 0. Can I treat this as y square minus y minus x square plus 2x minus 1 equal to 0? Now, is this appearing like a quadratic function of y? Then my roots of y become minus b plus or minus root of b square minus 4 times a times c, that is x square plus 2x minus 1 by 2 into 1. Now, am I able to express y as 1 plus? We don't take plus or minus because every function must be mapping one element to one element only. So we take one of them and write this as 1 plus 4x square plus 8x minus 4 whole thing by 2. Am I able to express y as a function of x? Then this function is, the first one is, a is a explicit function. So this equation represents a explicit function. Now what about b case? If you look at the right hand side part of the function, that involves both cos y terms as well as sin y terms. But on the left hand side, I'll have only an algebraic function of x and y. So algebraic functions y combined with a sine and cos combinations of y on the right hand side, I cannot express y as a function of x. Therefore, the function b is a implicit function. Cannot be expressed in the form y equal to f of xy. Now what about the c case? When I take c, can I rewrite the given equation as x minus 2y is equal to e to the power of 2x, and then my 2y becomes x minus e to the power of 2x, or can I write y as x minus e to the power of 2x by 2? Is it an exclusive function of x? I am able to write y as an individual function of x. Therefore, c is a example for an explicit function. Now look at the d function. Tan of x minus y is cot of x minus y. So if I use fundamental properties of trigonometry, can I write x minus y as pi by 2 minus of x minus y? 2 times x minus y equal to pi by 2, or I'll get 2y equal to 2x minus pi by 2, or my y is x minus pi by 4, which is an exclusive function of x. Am I able to express y as a single function of x? Yes. So what kind of a function is D expression? It is also a explicit function, right? So if I can express y as an individual function of x, then it is an explicit function. If I cannot express y as a function of x alone, then it is a implicit function.